Hello friends, welcome to CEC live lectures. I am Dr. Pavitra Bharadwaj. I am Associate Professor at the Department of Computer Science in Jesus and Mary College. So in the last lecture we were talking about the concept of process scheduling and process management by the operating system, and we were talking about the various operations which take place in processes. For example, how processes are created, how resources are allocated to the processes, and we were talking about scenarios under which process termination takes place. So one of the most normal and the generic process by which a process terminates is that it has completed its execution by reaching its culmination, the last statement, and then it will call the exit system call and the process is going to terminate. So when we say that a process is going to terminate, we mean that all the resources like the physical and virtual memory, all the files, the input output buffers, they are all deallocated to the operating system, they are given return back to the system. Besides the completion of the process, there is other possibilities which will lead to process termination. So a process can cause the termination of another process also. This is by an appropriate system call. So a process may terminate the execution of children processes using the abort system call, right. So it is also very important that the process, no process is allowed to terminate another process. A process can terminate its own children processes, its own child processes, but not the other process. Otherwise users will start deleting each other's processes. So it is basically only the parent process which can abort the which can terminate the child process using the abort system call. So there are multiple reasons why a parent would sort of terminate a child process. So first is that the child has exceeded the allocated resources, the task assigned to the child is no longer required, or the parent is exiting and the operating system does not allow a child to continue if its parents terminate. So in either of these three possibilities, a parent process would want that a child process should be terminated and it will go for an abort system call. Now some operating systems, they will not allow the child to exist if its parent has terminated. So if a process terminates, then all the children of that process must be terminated. So this type of termination is known as cascading termination. So cascading termination means that all the children and grandchildren of the process are terminated by the operating system. The termination is initiated by the operating system. There are some other operating systems which may allow this. So in those cases we don't see a cascading termination, but generally this is what is witnessed in most cases operating system. So the parent processes may wait for termination of a child process by using the wait system call. Now the call returns status information and the process ID of the terminated process, so that the parent can tell which of its children has terminated. So when the parent process will send a wait system call, in return it will get the status information of which processes are terminating. So a process that has terminated but whose parent has not yet called wait is known as a zombie process. So this is when a parent is terminating, but when a process terminates, but actually in the process table the entry still shows, because the parent process is running. Until the parent process will call for a wait, the resources and the entry for the process in the process table will remain. So till the time the entry is remaining in the process table, the process is known as a zombie process, because actually it has terminated but its entry is showing. Although this happens for a very short period of time and all processes go into this zombie state for a small period of time, but after that, once the entry from the process table is deleted, is removed, then the process stands terminated. On the other hand, there can be a situation where a process is terminated without invoking a wait process. So in that case the parent is not there, the parent has terminated now and the children are still remaining. So that scenario may be known as, in those processes actually whose parents are terminated, is known as an orphan process. Now processes, when we say that processes are executing concurrently within a system, so they may be, concurrent processes could be independent processes or they could be cooperating processes. So when we say cooperating processes, we mean that each process can affect or be affected by other processes, and they are also sharing data amongst each other, right? Whereas when we say independent processes, so they mean that these are neither affecting nor they are getting affected by other processes which are executing at the time. Now there can be, in case of cooperating processes, there are multiple reasons, why the cooperating processes exist, or what is the reason why should, these processes affect each other. So first reason could be information sharing, that is the processes, they are sharing information, they are sharing certain variables with each other, and because of this the communication is going on. Then sometimes, for speeding up computation, the task is divided amongst multiple processes, and therefore those processes they execute concurrently, but there is an exchange which is happening between them. Then modularity is also another concept where the process is broken down into simpler functions, and each function therefore returns a value to some other function. So therefore in those cases also the processes are done, and also for the sake of convenience of users, when multiple, say on a system when multiple programs are run by the user, say for example it's, the audio player is also running, the text editor is also running, a DBMS application is also running. So in that case, to allow that kind of convenience for the user, the cooperating processes may be needed. So cooperating processes, they all the time they need communication between each other, they have to talk to each other because they are constantly sharing information. So this phenomena where, two cooperating processes are, communicating with each other is known as inter-process communication or IPC. So for inter-process communication, basically there are two models, which are followed. First model is known as the shared memory, and the second mechanism is known as the message passing mechanism. Now in case of shared memory mechanism, a region, as the name itself suggests, that a region of memory is created, is established, and that is shared between the cooperating processes. So processes can exchange information by reading and writing data to the shared region. So therefore otherwise, this is not allowed, this restriction has to be removed, because in most operating systems there is a restriction on one process accessing the variables or data of the other process. But for inter-process communication through shared memory, this restriction has been removed, it has to be removed, and processes they can read and write data in the shared region, they can access the variables which are there. Then another mechanism, the second mechanism is message passing, in which messages are exchanged between the cooperating processes. Now messages are exchanged, of course they are exchanged using the various kinds of system calls. So if we look at this diagram, in this the first part, the A part shows message passing and the second part shows shared memory. So if we can see that, a portion of memory has been established which is shared between process A and process B, and both processes are reading and writing data through the shared memory. Whereas in case of message passing system, there is no shared memory and the processes are communicating with each other using specific system calls or using specific messages which are discussed. So shared memory basically, it requires that processes establish a region of shared memory and it resides in the address space of the process, creating the shared memory segment. So other processes that wish to communicate using this shared memory must attach themselves to their address space. So there is a common address space which is created, and all processes which want to communicate with this process using this mechanism, that shared memory, must attach their address space to this address space which has been created. So now once the address space has been established, once the shared memory has been established, now they can exchange information by reading and writing data in the shared areas. So this form of data and the location are determined by the processes, and this is not under the control of the operating system. The shared memory, once the area has been demarked as the shared memory area, then it is out of the control of the operating system. So the processes are also responsible for ensuring that they are not writing to the same location simultaneously. So there are concurrency control mechanisms which will ensure that two processes are not using or not accessing the same memory location. Now this scenario can also be understood, the paradigm of cooperating processes can also be understood in terms of the producer consumer paradigm. So the producer consumer paradigm actually looks at the whole scenario in the way that producer will produce information and the consumer process will consume information. So if the best example here could be like compiler is a producer. Compiler processes will produce assembly code which is consumed by the assembler. In turn, assembler will produce the object modules which are then consumed by the loader modules. So this is how the one process produces information which is consumed by other process. So we can see that there is a dependency between the two processes. Another very commonly cited example of client and server paradigm is also a producer consumer, where the client basically it produces the requests and the server will produce the response. So the server is actually producing the information, or the server is producing the the data which is actually consumed by the client. So producer consumer means that there has to be some kind of, they have to run concurrently, both the processes, the producer process and the consumer process, they have to run concurrently, and they must have, because they are running concurrently, they must have a available buffer of items that can be filled by the producer and emptied by the consumer, and this has to run in a synchronized manner. Synchronized manner means that when the producer is producing, the consumer should be ready to consume at the same time. If the consumer is not consuming and the producer keeps on producing, then the buffer is going to be full. Otherwise, if the consumer is consuming the data or the information which is not being produced by the producer, then also there will be synchronization problem. So the action or the activity of both the producer process and the consumer process has to be synchronized. So in this case there are two types of buffer. When we talk about this space from which both are actually taking the items is known as, there are two types of buffers that we talk about. First type of buffer is the unbounded buffer. Unbounded buffer means that there is no size. Unbounded means there is practically no limit on the size of the buffer. So the producer can go on producing even if the consumer process is not consuming. But most commonly what we see is a bounded buffer, where there is a fixed buffer size and the consumer must wait if the buffer is empty, right, and the producer must wait if the buffer is full, because there is a limit to the size of the buffer. So endlessly they cannot go on producing or consuming the information. Then for inter-process communication, when processes are communicating, they have to synchronize their actions. So there are different mechanisms. So another mechanism, like what we were talking about shared memory, the next is message passing. So for inter-process communication through message passing, the processes will communicate with each other without any kind of shared variables, any kind of shared memory. They will synchronize their actions through system calls. So it is particularly useful because in a distributed environment where communicating processes, they are residing on a different computers, they are connected by a network. So in that case they cannot have a shared memory. They cannot have a region where both the processes can access. So there they need a message passing mechanism. Otherwise also in most systems now message passing method is more preferred for inter-process communication than the shared memory method. So in case of shared message passing through inter-process communication through message passing facility, there are two operations which are done. First is the message is to be sent, and the second is that the message is received. Now the size of the message could be either fixed size or it could be variable size of message. Now again all these things are dependent upon the operating system which is in which we are viewing at. So different operating systems may have different kind of implementations of this mechanisms. So if process P and process Q, they wish to communicate, then the first thing that they need to have is to establish a communication link between them. Once the communication link has been established, then they exchange messages via the send command or the send call or the receive call. Now there can be several implementation issues which one can perceive in this kind of scenario where processes are sending messages and receiving messages. That is, first is how the link is to be established. Then can one link be associated with more than two processes, and how many links can there be every pair of communicating processes, like one process can be connected to how many links. Then what is the capacity of a link, how much message can go from the link at a given time, that is the size of the message, right, whether it is fixed size or variable size message, can the link accommodate that kind of size, and whether a link is a unidirectional link or it is a bidirectional link. So there can be several issues which may crop up when we are looking at this kind of communication using the message passing. So implementation of the communication link will require various aspects to be looked at. So first type of issues which we look at are the physical issues, that whether we would like the communication link to be implemented using a shared memory, or whether we would like to look it in the form of a hardware bus that we use for say like network, or we want to develop the communication link through a network of systems. Then if we look at the logical concerns of or the logical factors which determine the communication link, so whether the communication link have to be direct or indirect, whether they have to be synchronized or asynchronous. Synchronized and asynchronous means that when one process is sending the message, is the other process ready to receive the message at the same time. That is, both the sender and the receiver have to be available and ready for the communication, and whether we want automatic or we want explicit buffering. So when we are talking about these communication links, all these factors they may play a very crucial, very important role. Then another aspect which is related to inter-process communication is the naming. Now processes that want to communicate, they will have to refer to each other, right? So they can use either direct or they can use indirect communication for the purpose of referring to each other or for the purpose of communicating with each other. So under direct communication, each process that wants to communicate must explicitly name the recipient or sender of the communication. In this scheme, the send or the receive primitives are defined as send process P the message which is given, or send a message to process P, or receive Q message means receive a message from process Q. So in this case, the P and Q are the processes which are communicating through the communication link. A communication link in this scheme will have certain properties. Now what are the properties? That the link is established automatically between every pair of processes that want to communicate. So the processes need to know only each other's identity to communicate, that is they need to know each other's name. A link is associated with exactly two processes, and between each pair of link each pair of processes there will be only one link. So these questions which we raise at the implementation level, they need to be addressed using the particular paradigm that we are using for message passing communication. Then with indirect communication, the messages are sent to and received from mailboxes or ports. Right. So a mailbox, it can be abstractly viewed as an object in which messages can be placed by processes and from which the messages can be removed. Now here also each mailbox will have a unique identification, and a communication link in this case will have the properties like the link will be established between a pair of processes and only the members of the pair have a shared mailbox. A link may be associated with more than two processes, and between each pair of communicating processes a number of different links can exist. So we see that in this case also, whether we are talking about a mailbox method or we are talking about the other method, the implementation of the communication link may differ. So we have discussed in detail in today's lecture about how inter-process communication will take place and how process scheduling and process synchronization is achieved by operating systems. So that will be all for today's lecture. Thank you. Keep watching CEC Live.